So remember, we're continuing this problem. We're trying to find the tension in each of these three cables. Three cables connect at point A to support this 60-pound load. We're trying to find the tension in all three. To do that, I need to be able to describe the direction of those three cables, which we've now generated in the previous video. We generated unit vectors to describe their directions. So now we're trying to find tension, which are forces. What's a good tool for finding forces? Well, Newton's laws are good tools for finding forces, and this is being supported in equilibrium. So a good tool for analyzing forces would be a free body diagram. So if I could draw a free body diagram of A, not A, because that's where all of these cables are attached, it's not a bad place to start, and there's a known thing attached. There's a known force attached to that cable also. That's 60 pounds. So if I were to draw a free body diagram at point A, I would just draw a dot A down here. Try to get all three things in there. So I'm just going to draw A. Now I do know that I've got this 60-pound load. I'm going to go ahead and draw it off screen here. I've got this 60 pounds going straight down in the Y direction. Okay. I'm sorry, right straight down in the Z direction. Normally that's Y, but it's a three-dimensional problem, so up and down the Z. Okay. Then I'm going to draw my AB vector. It's entirely in the X direction. So I'm going to draw tension AB. It's entirely in the X direction, so that's the direction I'm going to draw. I'm going to draw X back and forth this way. I'm going to draw Y back and forth this way. We could draw it, again, just from the original problem. Z is up and down. X is down to the left is positive. Y is down to the right is positive. And the opposites of those would be the negatives of those directions. So if I draw vector C then, AC, tension AC. So tension AC is going to have these three components. So 12/17 of AC is going to be in the negative X direction. So I'm going to write out here 12/17 tension AC. Notice I didn't put a negative sign on it here. I've already drawn it in the negative X direction. So there's no sense in adding another negative sign to it in this case. All right, now these are going to get a little busy. I'm drawing the Y direction. It's always kind of a challenge trying to stack these in such a way that you can understand which directions they're going. I probably should have drawn this 60 pounds down here at the tip of that arrow, but that's okay. My Y direction here, this is a positive Y, 9/17 TAC. And then going up in the positive Z direction, 8/17 TAC. All right, so that's all the AB tensions, that's all the AC tensions. There's three components in the AC. Let's look at AD. So let's push that up so we can see that still on the screen. So AD, and again, you can reduce these fractions if you like. I'm going to leave them as is so we kind of keep track of where they came from. AD also has a negative X direction. 12/14 TAD. I'm not going to add the negative sign to it because it's already in the negative X direction. Same thing in the Y direction here. I've got a Y direction of 4/14, or if you like, 2/7 TAD. And then it has a positive 6/14 in the Z direction. So out here, 6/14, or 3/7 if you like, TAD. Now I have a free body diagram, and this is my preference most of the time is to draw my forces in their resolved components when I draw a free body diagram. The reason I do that is because then when I go to write equilibrium equations, they're pretty easy to write. And I'll show you what I mean. Sum of forces in the X direction. Sum of forces in any direction has to be 0. It's in equilibrium. So if I add up all the forces, that should equal 0. So if I add up all the forces in the X direction, that's this way. All right, remember, this is my X direction, is this way. So these are the forces in the x direction. I've got in the positive x direction TAB. All of TAB is in the positive x direction. In the negative x direction, I've got 12 over 17 TAC. And then also in the negative x direction, minus 12 over 14 TAD. Those are my x direction forces. Okay, now I can go through and add my y direction forces. Sum of forces in the y direction. That's also going to be 0. So in the y direction, I've got, in the positive y direction, I've got 9 over 17 TAC. This guy. Right, this is in the positive y direction. This is in the negative y direction. Minus 4 over 14 TAD. And then in the z, and that's all I have in the y direction. Now I've got z direction, up and down. Sum of forces in the z direction. Again, sum of forces in any direction should add up to be 0. And then we add the forces in that direction. I've got two positive terms. I've got 8 over 17 TAC. Also add to that 6 over 14 TAD. And then I've got one negative force, minus 60 pounds, the only known force there. All right. Remember our procedure. What are you looking for? We're looking for these tensions. Okay, what's known about the tensions? Well, we know the direction of these tensions. There was enough information given that I could construct a unit vector based on position vectors. Right? I can construct position vectors, find their magnitudes. That gives me the unit vectors. The unit vectors gives me the direction of those tensions. So that's all known. I had to organize that. And then what laws, equations, and tools? Well, again, what else is known is your free body diagram kind of becomes the known. And then what tools can I use with this? What laws or equations? Well, Newton's first law. So I add the forces in all directions being 0. And then we get down, okay, do you have everything you need? Do you have as many equations as you have unknowns? How many unknowns do I have? Well, I don't know the 3 tensions. But notice those are, yeah, I've got 3 equations, 3 unknowns. Solve. Just go do it. Don't complain about how much algebra it is. Don't complain about that you had to do 3 pages of work to get to this point. It took you 2.5 hours. None of that matters. We did the engineering work. We've got as many equations as we have unknowns. Now we just need to go solve. All right. So, how you do your algebra at this point is entirely up to you, as long as you don't break any algebra rules. I'm fine with it. I'm looking at this one. This is kind of this has the 2 unknowns in it. I can put one unknown in terms of the other. Right. So I would say TAC is equal to, I've got 4 over 14 times 17 over 9 TAC. You can convert that to a decimal if you like. Again, I've just solved for TAC from this equation. This is what I get. TAD. I apologize. Made a mistake. That happens. But because I was very clear about what I'm doing, it was easy to see the mistake. Yeah, so far so good. So now what can I do? Well, now I know TAC in terms of TAD. And here's another equation that has TAC and TAD in it. I can put this right there. And now I've got one equation only in terms of TAD. So what do I got here? I've got 60 pounds. I'm going to move it to the other side of the equation. Is equal to, I'm going to substitute in for TAC right there. 4 over 14. Again, feel free to reduce this or not carry around as many figures. I'm trying to do it in the way where I don't have to think too much about the math, so I can talk to you while I'm writing it out. And sometimes that works, sometimes it doesn't. I think that's correct. Plus 6 over 14 TAD. Okay. Now I will let you pause and do the algebra there. Go ahead and do the math there. I'm going to do it here with you. All right, so let's see. 4 times, well, I don't have to do the 17s because they're going to cancel. 4 times 8 divided by 14 and divided by 9. So this one is 0.253. I'm going to carry too many digits right now because we're going to round them off later. Okay if you carry too many digits now. And then 6 over 14, that's just 3 divided by 7. 0.42857 TAD. Add to that the 0.25397. There might have been, like, I didn't try to do it by fractions. You might have been able to have a nice discrete value for that. A rational value, I don't know. Okay, I'm going to invert that and multiply that to 60. And it's going to be, so I'm getting here, you can see I'm getting about 87.9 if I round to 3 significant figures. Pounds. If you're getting something different, please leave it down in the comments. You watched what I did. I could have just as easily made a mistake there. Now I've got a value for TAD. I can plug that in here, and that gives me TAC, right? So I've got, I should have left that on the screen. 87.9. Multiply by 17, multiply by 4. Divide by 14 and divide by 9. Again, I know there's probably some simplification you could do there. And by the time I did the simplification, I could have just as easily plugged up my calculator. So here we are. At least that's my theory. 47.4, we'll say 47.4 pounds to round to 3 significant figures. Now I've got a value for TAC and I've got a value for TAD. And now we just got to go back to TAB equation and plug those in. Okay. You've got values now for those. I'm going to let you pause and go get a value for TAB. All right, these are the values that I calculated here with you. And that's also looking back at my notes for this problem. Those appear to be the correct values as well. At least that's what I have in my notes. That's from a few previous times of teaching this course, so I'm comfortable with those. If you're getting something else, you want to leave it in the comments. We can try to help you find a correction or an error. If somebody does leave something in the comments, let's not be hateful with them if they made a mistake. Let's just kind of help them find what they've done wrong. That's definitely how I'm going to go about it. I'm going to delete anything that's negative. So yeah. Questions for me? What questions do you have? This is a good problem, honestly. It's I don't know. It might be a bit much for an exam, but it's really not. It's kind of about as straightforward as we can make one of these problems in 3D. They get a little tedious in terms of the algebra and the math involved. That's just kind of how it is. But you can see if you have a nice, clear, thoughtful progression as to how you work through the problem, then it's easy to identify any mistakes, and it's actually harder to make mistakes because the problem's you've kind of organized it nice and thoughtfully. And keep in mind, what you're seeing here probably is not what my first draft of this problem would look like. I ask you guys to work these on engineering paper. I would encourage you to kind of rough it out quickly on some regular paper, some cheap paper first, and then what you actually put on engineering paper or you actually put in your PDF you're going to submit for homework. That's probably your second or your third draft, honestly, because getting here, this is not a simple problem, but you do want to be kind of practice at being able to work through those. All right, I feel like I'm rambling a bit. Hopefully this helps. Let me know what questions you have. I think that's about all I'm going to do for Chapter 3. I think the next video we'll start looking at Chapter 4.